Hey guys, Mr. Gibson here. I'm going to show you guys this time how to calculate the average rate of change over an interval of the function. Okay, so average rate of change is basically just an approximation of the slope along a curve. And we can only do that along an interval, meaning like a certain distance along the x-axis. Because what makes a curve is if you look at this, there's no constant slope along a curve like you have on a line. Okay? So we have to get some sort of approximation. We can't call that a slope because it's not truly a slope. We're going to call it an average rate of change. But I'm going to let you recall that the slope formula is if you have 2 points, x sub 2, y sub 2, and x sub 1, y sub 1. To find the slope, you just find the difference in the y's over the difference of the x, rise over run. Okay? Same idea is going to apply here. So if you see here we have this curve, and here's our interval from A to B. Okay? So at x value A, we have some y value f of A. That's represented by this point, A and f of A. F of A is just your output when you plug in A, which of course is your y value. Same thing here. Plug in B, okay, because that's our end of our interval, and the y value or the output value is f of B. Okay, so it's, same thing as your slope basically. But as you can tell, look, the slope's different along this line. So what we're going to do is we're going to find the slope of a line between these 2 points. We're going to call that the secant line. Okay, I wouldn't worry too much about what a secant line is, but that's what the slope. That's the slope that we're finding. Obviously, it's not the slope of the whole curve because there's a different slope at every point of the curve. But we're going to find this approximation, this average. Okay, so let's see. Let's call this y sub 2, so that's f of b, minus y sub 1, f of a, x sub 2 is b, x sub 2, x sub 1 is a. Okay, so that's our average rate of change formula. It's basically the same thing as slope. All right, so here's an example. Okay, I have the function x squared minus 2, and I want to find the average rate of change between -1 and 3. Okay. So at -1, the output is -1. I just plugged it into this equation to find out. At 3, the output is 7. Okay? So let's see. We have 7 minus -1. So those are our outputs. Okay? And then you have 3 minus -1, your inputs. Negative and a minus. A minus and a negative is a plus, so that would be +8. A plus here, that would be 4. Our average rate of change is 2, okay, along that graph. Now, sometimes we're going to see tables, right? We're not given, in this case, we have f of x equals 3 times 2 raised to the x, an exponential. Again, it's a curve, so it's not going to have a pure slope. But what we're going to find the average rate of change on the interval from 0 to 4, and we're just given this table, okay? Same idea, though. Okay, f of 4 minus f of 0 over 4 minus 0, okay? If I look on the chart, f of 4 is 48. F of 0, the output at 0 is 3. And 4 minus 0, because that's just our interval, 45 over 4. Can't really reduce that. I'm just going to leave it like that. I like improper fractions. Thanks for your attention.